Hey, so here's some of the questions for the standard 1.1. Okay, so we have the surds. Okay, so again, with a surd you have to think of two numbers that multiply together that give you the 12. One of the numbers you can actually take the square root of, and it actually leaves a whole number. So think about root 3 times root 4. Root 3 we can't get a whole number from, but root 2 we can, so that's going to be 2 root 3. And then with 27, then think of what, 12 root 9, so 9 times 3. Okay, so 9 times 3 equals 27. We can take the square root of 9, that gives you 3. We can't take the square root of 3, so that sticks with 3 root 3. So that's 2 root 3, and 3 root 3, and 32. What times what gives you 32? So we can do 2 times 16. Now we can't take the square root of 2, but we can take the square root of 16. That's 4, so that's going to be 4 root 2. Right, so there's some examples, and I think there's just one less for you to have a wee go at. Now, if you're actually simplifying these questions here, is y to the power of 4 times y to the power of 3. Remember, when you're simplifying these with the indices, you need to keep in mind that you add these. Okay, so that's the equivalent of y to the power of 7. Incidentally, if it was y to the power of 4 times y to the power of minus 3, you're still adding these together, so that would be y to the power of 1. If you're dividing them, so if it was y to the power of 4 divided by y to the power of 2, you take them away. Okay, so that's y to the power of 2. So we've got an example here, it's 2x to the power of 5 divided by 4x to the power of 2. You look at the coefficients, solve these first, so 4 divided into 12 is 3, and then it's x to the power of 5 divided by x to the power of 2, so you subtract indices from each other, so that's x to the power of 3. Okay, so you just need to remember the rules for it. Next one, there was a wee question, it's to do with scientific notation. And what we've got here is you have 3.1 times 10 to the power of 7. You have, and that's just for 1 year, so I think it's to do with how many seconds are in a solar year, so they're wanting you to work out, well, what about 5 years? So all you do there is you just say 3.1 times 10 to the power of 7 times 5. You then just get your calculator, you then go 3.1 times 10 to the power of 7 times 5. Okay, and with scientific notation, you've got a wee decimal point and you count the numbers after it. Okay, so you got 1.55, okay, and that is 1, 2, 3, 4, 5, 6, 7, 8. So it's times 10 to the power of 8. And that's your answer there. So that was some of the answers to the homework, and some other examples that will give you a wee hand with the first part of the homework, which was expressing formulas 1.1. Right, so here are some examples for expression formula, standard 1.3. So what we've got here is, I'll just do the first example. So x plus 4 brackets x plus 6, and we're dividing that by x plus 6. So we just look at what we've got in common. There's 1x plus 6 and there's 1x plus 6 there, equivalent of that. So you just score it out, and that gives you x plus 4. There's another one in which it's x minus 6 cubed divided by x minus 6 and x plus 4. Now you could treat it the same way as indices. That's equivalent of x to the power of 1. So we know we subtract them. So that equals x minus 6, and that's squared, over x plus 4. If you're not confident doing it that way, you could just write it out. So x minus 6 cubed is basically x minus 6 times each other another twice. So if I'm just writing this out, what we can then do is that one cancels out with this one. So what we're left with is 2 watts of x minus 6. So if it's 2 watts times in each other, we'll just square it, and that's x plus 4. Okay, and we'll look at some fractions next. So if I just have a wee, we'll just have a wee look at the first one. So it's plus 5 over 8. What we'll do is we times these two together, okay, times that by that, and times that by that, okay? And that's how you answer that type of question, and it's the exact same. Well, actually, may as well actually answer the thing. So that's 24 plus 25. Divide that by 40, and that equals 49 divided by 40, which is equal 1 over 9 over 1 9/40ths, as it were. Okay, now if it's an algebraic one, it's just there. So this one there, 6 over x and 3 over y. So again, multiplying these two together, we then times that. The exact same for subtracting as well. So that is 6y plus 3x over xy. Now I'll do one that divides, right? So 5 over 6. So if it was subtract, it's the exact same technique, okay? Divide by 3 over 2. Or 2 over 3, should I say. Right, so what we do here is we rewrite this, but we're going to do the opposite operation of divide, and that's times, and we do the opposite here in terms of we have the 3 over 2 this time. And then you just times that by that, and that by that. So that is going to equal 15 over 12. And you could say that is equivalent of 1 over 3 over 12. Okay, so whether it's fractions or algebraic fractions, the same rules apply. So that was 1.3. Right, and here's one of the examples of calculating the gradient from 1.4. So I'll just take the first one. So there's one coordinate 6 and 3, another one's 8 and 4. We know that the formula for the gradient is m equals y2 minus y1 over x2 minus x1. I'm just going to call this x1, this is going to be y1, this is x2, and this is y2. So we just plug these figures in. So that's going to be 4 minus 3, 4 minus 3 over, that's going to be 8 minus 6. And that gives you a half. Okay, so that's your answer, and that's the technique.